Good morning, everyone. Welcome to Lockdown Webinar number 4. My name is Keira Proctor and I'm the Managing Director of the A Proctor Group Limited, and today we're talking about acoustic floor systems. These days we're probably better known for our construction membranes, but we've been involved in building acoustics for a very long time. Our ProFloor Dynamic battens received their BBA certificate in 1989, back when my father Alan was running the business. In today's webinar, we're going to look at how sound transfer in building works and what regulations are applicable across the UK. We'll finish up by taking a look at our range of flooring systems designed to reduce the impact of noise on building occupants. It's estimated that up to a third of UK households experience noise-related problems, with a third of these related directly to noise from neighbours. As well as an increase in living density and more construction of flatter developments, widespread use of home cinema systems and hi-fi equipment has contributed to driving this rise. Design trends such as laminate floors or stripping carpets to expose floorboards have also added to the problems. Before we consider how to address these problems, let's begin by looking at some of the terminology used and how this relates to buildings. There are two types of sound we're concerned with when designing buildings: airborne sound and impact sound. Airborne sound. Miles, come on, baby. No. Airborne sound typically originates from sources like TVs, home cinemas, and stereo systems. Human voices are also a source of airborne sound, but it's generally bass frequencies from entertainment systems that create the most issues, as these are the most difficult sounds to restrict. This type of sound is caused by the source vibrating the air to create sound waves. When these waves strike the walls, roofs, or floors of a building, they are converted into vibrations in the structure, which then transfers the sound around the building. This sound is then re-emitted by other surfaces in the same way as a speaker generates sounds. Airborne sound can come from outside the building as well as within, and typically travels in all directions throughout the structure. Building regulations therefore require most building elements to have some degree of airborne sound resistance built in. Impact sound. Impact sound occurs when mechanical impacts cause vibrations in the structure directly rather than via an external sound wave. Impact sound comes primarily from footsteps, and it's here that bare floorboards or laminate flooring cause problems, as carpets and underlay contribute a lot to reducing these impacts. As with airborne sound, these vibrations pass through the structure before being re-emitted in other areas. Unlike airborne sound, though, the regulations regarding impact sound are typically only concerned with sound transmission between the floors of a building. We'll now take a look at some of the properties of walls and floors that can affect the sound transmission within buildings. A thorough understanding of these factors is important when designing structures to perform well acoustically. Mass. When considering acoustics, the mass of the wall or floor is a very important factor. The heavier the element is, the harder it is for incoming sound waves to induce any vibrations. This has the effect of reflecting a greater proportion of the incident sound waves, resulting in less sound being transferred into the structure. Heavy elements such as brick walls or concrete floor slabs are therefore better able to restrict the passage of sound, particularly those problematic low frequencies, than lighter timber frame structures. It is, however, not always practical or economically viable to use high-mass construction. This is particularly true in refurbishment projects, where increasing the mass is often impossible. Stiffness. The stiffness of the structure is important as it dictates the ability of the structure to vibrate. While the mass of an element restricts the absorption of sound waves, the stiffness restricts their transfer once absorbed. The property governing this is the modulus of the element, in other words, the ratio of depth to length. A shallow and wide beam will vibrate more than a deep and narrow one, allowing for a greater amplitude of vibration and therefore more sound to be transferred. A related property here is resonance. Every part of the structure will have a frequency at which it vibrates more readily. This is the natural or resonant frequency. If the natural frequency of, for example, a wall, coincides with a frequency in the incident sound, the effect may be able to amplify rather than reduce the sound. Careful consideration of the stiffness and frequency response is therefore necessary to avoid this. Isolation. An effective way to prevent sound transmission through structures is by physically isolating one side from the other. This can be achieved by either using entirely separate structural elements, such as independent floor and ceiling joists, or by using resilient mountings for floor and ceiling surfaces. This approach aims to break the pathway for sound to travel through the structure from one side to the other. With independent structures, there is an actual discontinuity in the pathway, leading to the best acoustic performance. However, this approach results in very thick wall or floor elements, so is not always practical, and as such tends to be used only when acoustic performance is the primary concern, such as in recording studios. Resilient layers are usually a cheaper, thinner and lighter weight solution. They can be applied in the form of floor deck or batten systems, as ceiling mounting bars, or commonly both. These work similarly to car suspension by damping the vibrations and reducing the energy from the sound waves by allowing a degree of movement. These systems must be carefully matched to the loadings expected on floors, as heavy weights can damage the layer and reduce their effectiveness. Absorbency. Absorbent acoustic materials work by reducing the echoes within cavities in a wall or floor construction. This has the effect of breaking up the sound waves in these spaces. This reduces the overall energy transfer by converting the energy in the sound waves into heat due to friction between adjacent fibres. Fibrous materials such as mineral or polyester quills are usually used for this purpose, most commonly in timber or steel frame structures. If there are voids present, partially filling them with an absorbent material will generally help reduce the sound transfer. Flanking. Flanking transmission occurs when sound can pass around the sides of an element, for example, bypassing a floor construction by passing through the walls instead. This can result in elements with well-designed and specific acoustic insulation failing to perform as well as intended. Flanking transmission can be minimised by paying attention to how linkages between floors and the supporting walls are designed. However, outside of new build constructions, this can be difficult to achieve. It's therefore not uncommon in refurbishment projects to over-specify the acoustic insulation to account for the unknown quantity of flanking transmission. Acoustic floating floor systems will typically use a strip of foam at all perimeters to prevent a physical contact between the walked-on surface and the surrounding structure. Building regulations. The building regulations for acoustics have remained relatively stable since the mid-2000s. The precise details vary across the UK, with slightly different variations used in England, Wales, Scotland and Northern Ireland, but there's a lot in common which we will consider here. The regulations set requirements for impact and/or airborne sound transmission across separating walls between adjacent properties, and for airborne sound only within a single dwelling. Between dwellings, floors are required to resist both impact and airborne sound, and walls to resist only airborne sound. Between dwellings and commercial properties, such as shops or offices, only airborne sound insulation is required. Where a roof terrace or balcony is over a dwelling, impact sound insulation is required. These requirements are expressed by way of a single figure value, which combines the sound levels across the full spectrum of frequencies into a single number. Depending on the regional variations across the UK, this can be weighted to emphasise different frequencies or make the requirement more or less stringent. In general, though, acoustic requirements are expressed in terms of decibels, dB, of reduction in sound pressure. For airborne sound, this is expressed as dB dNTW, with a higher single figure value indicating better acoustic performance. For impact sound, dB LNTW is used, with a lower number indicating better performance. The requirements are reduced slightly for refurbishment and conversion projects to reflect the practicalities of introducing acoustic insulation into an existing structure. This can include period features that are listed or unknown existing details or defects that cannot be easily remedied. These single-figure values do not vary linearly with perceived loudness. A change of 10 dB in the acoustic performance equates to a doubling or halving of the perceived loudness. This makes the scale used very sensitive, but it also makes it difficult for the human ear to detect subtle variations in acoustic performance. Testing and compliance. Because of the difficulty in accurate perception by the human ear, an important aspect of the regulations is a mechanism to ensure compliance. Again, the specifics of this differ between the various parts of the UK, but pre-completion testing of at least some proportion of separating walls and floors features across the country. Acoustic testing is a complex process and should only be undertaken by those appropriately accredited by organisations such as the United Kingdom Accreditation Service, UCAS, or registered with the Association of Noise Consultants. Testing for airborne sound is typically done using an omnidirectional speaker to play a predefined pattern of noise which can be measured by sensitive microphones and sound meters in adjacent rooms. The figure quoted is the difference in sound levels across the partition, so a higher figure is better. The sound source used is usually pink noise, which has an equal power per octave, giving more weight to low frequencies than white noise, which more evenly distributes sound power. This shift in frequency is quite noticeable when the two colours of noise are played back to back. Impact sound is measured using a tapping machine to simulate footfall. Tapping machines use a camshaft to drop carefully calibrating weights in a precisely defined rhythm. This sound is then measured in the room on the other side of the separating floor. In the case of impact sound, only the level in the receiving room is measured, so a lower result indicates better performance, the opposite way around from airborne sound measurements. The equipment used to measure this sound must be very sensitive, so during testing it's critical that certain site conditions are met. The building under test should be more or less complete, with doors and windows in place. A lot of noise can transfer through openings, so it's also important that vents and ducts are in place, or their openings are sealed. Site noise should also be minimised during testing. Ideally, testing should be undertaken at night when no work is being done on site and noise from machinery and traffic will be minimised. Any extra noise from site work, etc., will lead to poor results or possibly even test failure, so it's in everyone's best interest to ensure the correct test procedure is followed. As an alternative to testing, designers can use approved robust detail constructions to comply with building regulations. These are standardised subfloor types to which pre-approved floor and ceiling treatments can be applied. Because these construction types have been tested thoroughly ahead of time and have consistently exceeded the regulation requirements, they can be used without testing, provided they are followed to the letter. The A Proctor Group have floating floor treatments to suit most robust floor types, with a range of systems approved in floating floor treatment, FFT categories 1, 2, 3 and 5. As well as floor type and acoustic treatments, robust detail also includes standard details for the junctions and connections between walls and floors in order to minimise flanking transmission. Acoustic floor systems overview. There are two principal types of acoustic flooring systems and a few other less common ones. Batten systems. Batten systems such as ProFloor dynamic battens are most popular in new build timber frame floors and are the top performing floating system. The extra depth introduced between the battens not only simplifies service runs within the floor, but also provides additional void space in which additional fibre layers can be added to boost sound absorbency. The downside to batten systems is that they tend to be thicker, so it may not be practical to apply to all floors if tying into adjacent floor levels is an issue. The A. Proctor Group supplies a range of batten systems to cover a variety of different project requirements and floor types. Deck systems. Deck systems are much shallower and can provide a good boost to the impact sound performance of a floor. However, they offer little scope to improve the airborne performance. For that reason, they tend to be more commonly used on concrete floors, where base floor mass does most of the work dealing with the airborne noise transfer. Deck systems are also a good fit for refurbishment projects, where floor-to-ceiling height may limit the scope for using a batten system. Systems like the ProFloor microdeck at only 17mm can improve impact performance noticeably while having minimal effect on floor levels, services and internal trims and skirtings. The A. Proctor Group's range of overlay deck systems are designed to provide the optimum balance of performance and thickness while accounting for the practicalities of working within existing properties which may not have ideal access. Other systems. Of the less common systems, levelling system allow a floor to be raised and levelled while introducing a degree of acoustic performance. This is useful in existing buildings where floors may be substantially off the level, or in new build where pre-stressed slabs may be used which have an inbuilt camber that can be corrected to give a smooth, level finished floor. The Proctor Group's ProFloor levelling system uses specifically designed resilient bases with packing pieces to accommodate variations in finished floor level from 51 to 203mm, while still delivering good impact and sound reduction. So that brings us to the end of the presentation, and we will now move on to the Q&A session. Good morning, everyone. Thank you very much for joining our fourth webinar during lockdown. And thanks to marketing for the surprise cat meow. My cat will be very pleased. I wasn't expecting that. I thought you'd cut it out. But a great example of airborne noise. And he interrupts me a lot more frequently than that, believe it or not. So at the Proctor Group, we've actually been producing acoustic solutions for over 25 years, and we were involved in the creation and actually setting the standard for the robust details way back in the early 2000s. And we have an in-house acoustic laboratory, and we manufacture most of our acoustics in Bulgaria and Scotland. Again, I'll just go through some kind of housekeeping rules and then introduce people. So questions, if you have questions, please type them into the YouTube live chat. You can also DM us on Twitter or email webinar@proctorgroup.com. Last week, I think, was probably the busiest week we've had of questions, and we're very happy to stay on and answer them. And equally, we will not be offended if you have somewhere else to be and you want to leave early. I said, I think a couple of weeks ago, you know, in British style, we don't like to upset people, but we don't see who leaves when, and we will not be offended if you don't want to stay for the whole Q&A session. You can receive personalised certificates for this webinar. Just follow the link in the description below, which is easy to follow, and you can figure out how to ask us for those and download them. We will be sending you an email after this. We love getting feedback, so there's a link to a survey on that email. I personally read them all, and we circulate it, and we discuss about what we could do better in the coming weeks. And so please, if you have time, fill them out for us. That would be fantastic. Next week's webinar is available to sign up for already. I think someone's put it in the chat here, but you can register now at proctorgroup.com/webinar. Next week, it's going to be about condensation in the roof space. So predominantly all about roof shield, which is an air permeable breathable membrane. So again, very informative and a very interesting one, and about a great product. Okay, and in that email, there'll also be a follow-up to the replay. So please circulate it to colleagues, children, whoever you like. If you feel they find it of interest, share as much as you can. So some introductions. I'll start with James Brackenreed Johnson, whose name I got wrong last week, which I got in trouble for afterwards, and I'm horribly embarrassed. But James is our specification manager covering the London area. He's been with us probably he is the shortest out of the three on the Q&A today, but comes with a wealth of experience across lots of different sectors and is based in Eastbourne. So welcome, James. Mark Lambourne from Ripley. So Mark's 34 years in construction, has been with Proctor Group before, and we lost him to pastures new, where he still remained in the sector, but as I said last week, we managed to fix him back. So he's now been working for us again for quite a while, and he's our development manager for high-rise and modular, and Sue Menier working just not too far from our offices in Blairgowrie, which of course are shut at the moment up in Scotland. 27 years with Proctor Group, has actually carried out a lot of acoustic testing both on site and in our laboratory, organises all of our certification, and a huge wealth of knowledge in acoustics. So please ask away. Okay, so I think that's it in terms of sort of housekeeping. I'll give you at the end. So we have a lot of questions via email, also on the YouTube feed. So I think I'll just start with some of the ones that have come into the webinar at Proctor address, and I'll go back to that. And I say every week, please bear with me because they're coming through all these different platforms. So we will try and answer them all, and we'll just stay on as long as we like to get them done. So Sue, if I can start with you. Quite a generic question here. What technical services do APG provide?
Okay, we provide quite a lot of services to our customers. In terms of acoustics, then we will provide specification advice. We'll look at drawings, we'll look at the building and offer advice as to what's the best solution for you. Once it's on site, we can give on-site installation advice. From a specification point of view, we can provide batten layouts, which will show you exactly where to place the battens, what centres, etc. And also a takeoff service as well. So we can, at the tender stage, we can obviously do a takeoff service. And as you mentioned earlier, we've got our acoustic laboratory, which is available as well for any R&D work, etc.
That's great. Thank you very much. And one from Mike, do your products comply with robust details?
Yes, they do comply. Our batten system was actually, the ProFloor Dynamic batten was actually the benchmark product for the FFT1 construction. So we have batten systems that comply with FFT1 and FFT3, which is the shallow batten system. Also the Scottish FFT80, which is slightly deeper compared to the English 70mm void. We have a levelling system, which is an FFT2, and then we have our deck systems, which all comply with FFT5.
Okay, that's great. Thank you very much. James, a question here on retrofit. How would you address a retrofit project?
My apologies. From an acoustic point of view, obviously what we take into consideration first is the use of the building. So obviously, according to document E, there's different dB ratings for impact or airborne, depending on whether it's new build or retrofit. So we take those into consideration, and the use of the building, whether it be residential or commercial. We then look at the floor build up to see whether it was timber, whether it was concrete, whatever it may be from there, to decide what materials to utilise. We look at the floor levels to make sure that if there's any sort of evening out of the floor levels that are required, then we're utilising our different systems to make sure that if the want is to have that continuous layer throughout the floor area, then we can provide that. But ultimately, the most crucial part is always about the detail side of things. The devil is in the detail. So the junction details between the partition walls, party walls, and the external walls. That's what we need to know as well, the build-up, to stop any flanking transmittance through those areas as well to lower floors or indeed floors above. So as much information as possible. And as Sue and Keira both mentioned, we do all the R&D into these. So we'll provide the CAD drawings as well for the floor area drawings, and there's be as much assistance as possible.
Okay, great. And James, you've been doing a lot of work on our fire division, so perhaps you can take this question as well. From Tim, thank you for the question. Can a fire stop sock in the facade cavity negate flanking transmittance?
Yes, dependent upon what sock or stop is being utilised. There are the mineral wool varieties or the rock wool varieties of fire stop, which obviously do well for acoustics. In regards to fire socks from the fire side, I do a lot more research into the product that you're using, especially in regards to the longevity and lifespan of the product, because it's a bit of a bone of contention at the moment, especially in facade systems, regarding the lifespan and installation details of these socks in place. So again, in the detail, as long as the installation is done properly and the product is selected properly and specification is conformed to, then there shouldn't be any issues in regards to that. But ultimately, yes, it will assist in the reducing down flanking transmittance.
Okay, so it will have effect of some sort. Okay, great. Mark, a couple of specific ones coming in on the email. This is from Joan. We're converting an old mill building into luxury apartments. Built around 200 years ago, the timber floors are supported by a series of cast iron columns, which, due to the historic nature of the building, we intend to leave exposed as a feature. Nice. Have you past experience of similar projects?
Yes, we have. Morning, everyone. Personally been involved in a number of mill conversions in Derbyshire, Staffordshire, Notts, Yorkshire. I think as a business we've done plenty up in Scotland, and we've probably got more on file that I'm not aware of. So these were sort of material use, change of use projects, and they typically feature, as you can imagine, luxury apartments. And I guess the people that are going to sort of move into these buildings recognise that they are historic buildings, and there's a desire by all parties really to retain the existing features. And that may include things such as the cast iron columns. The issue there is, of course, it's issues and problems with flanking transmission and sound transmission and all that type of thing. So it's not always practical to achieve the sound insulation standards within party. So there is some relaxation there, and certainly if you talk to building control and that type of thing, they can be quite sympathetic. A sound insulation test will still be required, and you need to declare the results. But I'd certainly recommend sort of getting involved at an early stage, and I've attended many sort of site meetings with architects and local building control just to demonstrate that everything that we're trying to do the best that we can, that what is reasonably possible to do to improve the sound insulation, and the other services we provide, obviously site training with the products to make sure that they're installed correctly and all that type of thing.
Okay, great. And can I just say, that sounds like a really interesting project. So we would be happy to be more involved in that. And just, the old mill into luxury apartments, just sounds really interesting. So if you need more assistance, please contact us again. One from Derek here, and then I'll come on to some of the YouTube questions. The levelling, Mark, if you don't mind as well while you're there, the levelling system seems an ideal solution for stepped and uneven floors. Can it accommodate a range of floor finishes, including ceramic tiles?
Yes, it can. I guess in apartment builds, you're always trying to encourage people to use soft coverings, but it is possible to tile on a range of ProFloor acoustic floor systems, but you need to be careful because tiles, they are very rigid. So we need to make sure that the substrate is rigid, stable, and really capable of supporting the additional loads without sort of flexing and that type of thing. So there's lots of factors you need to consider. With regard to tiling, you need to follow the guidance within BS 5385. And really I'd recommend sort of seeking advice from adhesive manufacturers rather than the tile distributor, because the tile distributor will sell you what is got on the shelf rather than actually what fit for purpose for the project. The other things you need to consider, because tiles are very flat, uniform, etc., and you're bonding all these different layers over the top of the system, you might need to consider ventilation below the flooring to avoid any issues with moisture and condensation and that type of thing. But in terms of the batten layout system, the levelling system, you really don't want to go any exceed centres greater than 300 mil. And that would be the case also with the levelling bases and the packets as well. So in terms of the build-up, I guess we'd be looking at an acrylic primer over the top of the finished floor. So you've got your leveling systems down, you've leveled those up, you've got your battens in place, and put your floor finish on top of that, acrylic primer. Then you want to use a flexible adhesive. So they come in various categories. So the flexible adhesive is C2, and then you'll bond on top of that a minimum 6mm thick tile backing board. And you need to mechanically fix that at 300mm centers. Make sure you don't go through, obviously, through to the acoustic floor system beneath. You can go into the battens, obviously, but not through to the foam, etc. And then on top of that, you really want to bond a decoupling membrane, again using flexible adhesive. Bond your tiles in using that adhesive, and then a flexible grout as well. And fingers crossed, you should be okay.
Sounds easy. Sounds easy.
Yeah.
And Mark, there's quite a similar question on the YouTube feed from, I read earlier, Marco, about asking for advice on integration of underfloor heating within our systems. Is that something you can give a bit of advice on?
Yes, we can integrate those, and again, I guess that would sort of accompany the tile finishes. Every project's different. We need to understand the system and all that type of thing. So yeah, if we could have details on that, just fire them through to yourselves at technical, and we'll be able to come up with a solution.
Yeah, so if you do have technical questions, technical@proctorgroup.com, and that'll go straight to you, Sue, along with the rest of the team onto it. So. Okay, Alan has asked, Sue, again, maybe this is one you could have here. Do you manufacture products to fit all regulations in the various countries, or do you produce a one suits all? So in terms of Scotland, Northern Ireland, England, etc. Okay.
Yes, obviously the regulations and the requirements are different throughout, obviously Scotland, England, Northern Ireland, and the South as well, actually. Scotland has the most onerous requirements. So our systems, obviously, if they meet our own Scottish requirements, then they're absolutely fine for the other nations as well. Both for impact and airborne, I say Scotland is more onerous compared to the rest of the country. So our systems will be suitable throughout the UK.
Yeah, so we would manufacture the sort of best performing to cover the Scottish regs, and it would be the same products supplied to all the geographical regions.
Absolutely, and even the robust details are obviously designed to, sort of be above the minimum requirements as well. So the fact that our systems are all robust detail certified, then there's no issue there.
Okay, great. Peter Cole has asked, again, Sue, just while we've got you here, if you could perhaps try and take this one as well. In addition to the 10 kilogram per square meter minimum density on plasterboard ceilings and particle board floors on joists, with acoustic wool placed in the joist void between, do we offer any cost-effective enhancement to improve the sound performance of this makeup?
Well, it will obviously depend on whether he's referring to impact sound or airborne sound. For airborne sound, obviously the ceiling system, the glass wool in between the joists. If it's a batten system, additional glass wool in between the battens, then obviously, yes, that's all improvements. We would supply, obviously, the floating floor treatment, which would be for impact sound.
That's great, thanks. James, Sam has said lifespan of product and recyclability.
Right, yes. The resilient layers of our products are polythene, polyurethane and polyester, which, unlike some of the original products, don't degrade over time. They don't sort of basically, through dynamic loading, don't sort of reduce down to dust. They stand the test of time. So what we say is that the product will last the lifetime of the floor. When it comes to recycling, obviously you've got the timber aspect, but in regards to the resilient layers, what I'd say is confer with your local council, your local scrappage areas. And yeah, in this day and age, there are quite a few out there that will be able to recycle the products, but please make the conversation first and find out exactly what's going on.
Okay, that's great. Let's have a look. Leslie Brown, Medway Council. Let's have a look. So reconversion of a ground floor flat into a shop, the acoustic reduction of 60 dB what are the typical values you can provide? Sue, is that one perhaps is that specific enough for you to answer?
It's not too specific. It will obviously depend on where you're measuring from. If it's a ground floor, was it a ground floor shop?
Ground floor flat into a shop.
Right, okay. So ground floor, if it's going to be a shop on the ground floor with flats above, the requirement will be for airborne sound. So the 60 dB is referring to airborne sound requirements rather than impact sound. What we would do is, obviously, we can have a look at what the construction is and give advice as to, you know, what can be done. It will also depend on whether they have access to the flat above as well, and what sort of works they're actually able to undertake as well.
Okay, and if that was a flatted development and a flat development above it, would be both airborne and impact sound, correct?
If it was a flat below and a flat above, then yes, you would need impact and airborne.
Okay, that's great. Thank you very much. Mark, if we can come back to you, one from Paul through webinar at Proctor Group. Converting an old public house into student accommodation due to limited floor to ceiling height, it's not possible to accommodate a batten system. What do we need to consider when selecting a shallow deck system?
Yeah, it's an unfortunate state of affairs where lots of boozers are being converted into apartments. So it's a sad day for all. Shallow deck systems, they don't really, because of their very nature, they don't offer the same level of airborne sound reduction as perhaps a deep batten system would, particularly on timber floors. However, we have successfully installed sort of pro-floor deck systems on both timber and concrete decks. There's a couple of options to look at. If you want to sort of achieve a little bit extra on airborne performance, then you perhaps want to look at our ProFloor XL Deck 31. So that's has a unique resilient layer, 13mm vertically orientated fibres. So these fibres actually sort of move like a spring, as it were, and that can offer additional airborne performance over a typical sort of chip foam deck that you know our competitors would use probably on the market. The bulk of those have a chip foam. With our Deck 26 and Micro Deck, the thinner 17, Micro Deck 17, these boards have a patented support strip along the long edge and the short edge of the board, and also a strip across the centre. And what this does, it actually prevents fracture on the board tongue and groove joints. So that's very useful. It just means that the floor will remain performing as it should without the tongue and groove joints sort of breaking. So that's something to sort of look out for when you're sort of considering which type of deck system to go for. We also have two grades of deck. We have the standard grade for standard load areas, but for kitchen and bathrooms, you may need higher point loadings up to 4 kilonewtons a square metre. So again, choose the right type of deck for the right type of areas.
Okay, so I was just giggling there because I saw one come through from John on the YouTube feed. I live in a 3-bed semi and I can hear my neighbours talking through the walls. Apart from telling them to shut up, what can I do? Well, you can borrow one very noisy cat called Miles. I can lend you him for some revenge. But realistically, I mean, between party walls, is there anything we can advise? It's not particularly a product area we can help with, but Sue, do you have any generic advice, or Mark, or anyone in particular that you can?
There are walling systems out there that you can actually, that you can install. Obviously, you'd need to consider the space that it takes up, whether you can accommodate that extra space. It'll probably be quite difficult to actually even, unless you do a sound test to see what not, how the wall is actually performing. It can be quite difficult to achieve a particular comfort level, because if you're aware of that noise, then you're probably listening out for that noise anyway. But as I say, there are systems out there which can help.
Yeah, but they would, as you say, probably increase obviously the depth of the wall unless you can get your neighbour to agree to do something as well. So good luck, John. Keep banging and tell them to be quiet politely. Okay, I missed one further up in the feed, I'm sorry, regarding the benefits of a deeper batten, Sue. Is that one you can answer as well, please?
Yes, a deeper batten has a few advantages. it will be better acoustically because you do have a greater, a deeper airspace. So that will give it an extra reduction in airborne sound compared to a shallow batten system. You then have the space to put potentially additional wool in between the battens, which again improves the overall system performance. And it provides obviously a place to install services as well, which you can't do with the deck system.
Okay, great. James, you'd mentioned earlier, sorry, Lorna had asked, are our systems in CAD? And you'd mentioned earlier, obviously, that's something that we can help with if we have the drawings. So I think that's adequately answered there. And James, there are lots of similar batten and decking products out there. As Proctor were one of the original manufacturers, have we developed any new or alternative products?
From a Proctor point of view, obviously we are a very innovative company and have been since our sort of conception in the 1600s. So I can't confirm or deny, but what I will say is obviously keep abreast of our website. And yes, obviously we're working on multiple different products to enhance them. And obviously from the innovation side, bringing new products to the market that we are obviously seeing holes in there that we can get our knowledge based into those areas. So yes, please stick with us and please keep looking at the website, and hopefully in the not too distant future there may be something to put into the market.
Absolutely, good answer. Yeah, I think it's interesting because a lot of the Proctor products sometimes are developed based on legislative change or customer requirement. So because our products are, in terms of performance, they're very well performing products, and we obviously develop them and sort of set a lot of the original standards. There hasn't been a huge demand to upgrade the performance of the products, but we have done different things, tried different foams, different product makeups to try and improve the performance. And we are actually working on quite an innovative new product design, which I can't go into too much detail. So as James said, keep an eye on our website. In fact, if we were all at work, we'd all be sitting in an R&D meeting right now because it's meant to be at 10 o'clock on the 1st of the month. So I'm missing that, but we're much happier to be here talking to you. Okay. Let's just have a quick look again at YouTube. Apologies for missing some. So Jim has asked, do we have any testing information on offset joist construction? Sue?
Yes, we will do. We have a huge bank of test reports that we've done over the years, and I'm pretty certain I can recall sort of like independent joists system. So depending on what he's looking for, we can certainly check our test database, and we can get in contact with him and send him some information.
Great. So again, if you would like to email Jim, technical@proctorgroup.com, see if you can have a look out for that if we do have anything. Great. Paul has asked, what product would you recommend for reducing impact sound to floor on a concrete composite floor? So wet pour on metal deck.
Okay, that is there is a robust detail for that type of floor construction, and any of our deck systems are suitable for over that type of floor construction.
Okay, that's great. Thank you very much. Mark, this is from Sean, we are a small regional house builder and have little experience of the refurbishment market and pre-completion testing. What support services are available to give guidance and avoid any potential costly remedial works?
Right, okay. Well, as you said earlier, we've been involved in sort of manufacturing acoustic floor systems, I guess actually for over 30 years, because if you think about the BBA certificate for dynamic batten, that was in 1989. So that's some 31 years ago. It's actually 31 years ago in 5 days' time that I married the current Mrs. Lambourne. And when it comes to sound insulation, that's one thing she's not been very good at. So, yeah, so we've been involved, as Sue said earlier, lots of test results. We were involved in actually testing prior to the requirement in Improved Document E. So there is a whole range of test results on various floor types. Our technical team obviously can provide specification support. And the regional managers out there can go out onto site, visit site, gain an understanding of the construction, offer advice on most appropriate floor systems, and provide installation training, and we can consult with the contractor, the client, and also get involved in meetings with the local building control officer. So it can be good to get these guys on board and give them an understanding what we're trying to do and trying to achieve.
Good, that's great, thank you very much. And if you are a small regional house builder, then please come to our webinar next week, which is all about roof shield. I'm sure that you would find that interesting. Okay, Robert has asked, would any refurbishment using deck systems, for example, have a positive effect on energy efficiency? Or is it usual to include insulation while doing any retrofit?
Sorry,
Mark, well, Mark, if you're happy to answer that, feel free. So yeah, so basically, when you're putting the deck system, would that have a positive effect on energy efficiency, or would they normally upgrade it with insulation at the same time?
Yeah, you need, particularly with deck systems, particularly if it's obviously with a concrete floor, you've got the mass of the concrete and all that type of thing. With a timber floor, you'd need to include some mineral quilts, etc., to provide absorption and that type of thing. So you'd obviously get a thermal benefit from the insulation. I wouldn't know, perhaps Sue can comment as to whether there's any thermal benefit at all from the deck system itself. I wouldn't have thought a great deal, to be honest.
It would be very, very minimal. I mean, like, you're talking only 8 millimeters of foam. So not very much thermal benefit at all. Not really.
Okay. Or if there was, it's not something that's measured, presumably, regularly.
No, I mean, and bear in mind, obviously, these floors are generally between two apartments anyway. So they're between two heated elements. So you know, there's not the same heat loss that you get on a ground floor, for example.
Okay, good. Okay, we have one here. I'm not sure this is actually a question from Gavin regarding the Adam Smith Theatre. Interesting. Okay, so they're about to start work on refurbishing the above theatre, and would be very interested in discussing acoustic and fire separation systems. So thank you for that, Gavin. Again, please email us at technical@proctorgroup.com. We'd be really interested to be involved, you know, especially in something like a theatre refurbishment. We find these types of projects really interesting. So please email us, and we'll happily chat to you offline about any further questions you have on that one. Okay, James, from Carol, another one from the email. How do you deal with partition walls between habitable rooms?
Right, okay. In regards to the floor itself, what you can do is you can treat the entire floor as one element, and therefore you can use the dynamic batten across the board, across the floor, as long as where your partition walls are coming down, you can double up on your dynamic battens, or indeed put a ladder system in there to make sure you've got that extra support of the partition wall. Depending upon your substrate, some would rather utilise the support batten instead, but what you'll get there is a diminished acoustic value because of the nature of the product. So what we generally do in this day and age is put in the dynamic batten, but more of them, in order to support that wall. If you're going to be doing, if the partition wall is going to be going down to the deck itself, and you don't want to go underneath it with the batten, then what I'd stipulate, as with anything, is pay close attention to any flanking issues, which is obviously constantly with acoustics, it's a massive issue. There's no silver bullet, but what I'll say is obviously pay attention to the details, send us the details, and we'll assist as much as we can do in order to reduce down that flanking transmission as much as possible. As we've alluded to already, dealing with the actual partition wall itself and negating any transfer of acoustics through there, we can sort of help you, but it's not something that we currently provide in our arsenal of products.
Yeah, so not dissimilar to the question about shouting next door. And Alan Lawler has said, actually, again on the party wall, if you can get one neighbour to do downstairs, other to do upstairs with minimal contacts, creating a shallow void. So again, similar to that sort of flanking effect. So a good point there, thank you. Okay, let me just go and bear with me 1 second here. So Michael's asked, do we provide ceiling only acoustic systems for an individual flat? Now, I don't believe we do we, Mark? That's not something that we'd be able to help.
No, we don't. We can give advice on suitable ceiling build-ups, featuring things like resilient bars and this type of thing, or independent ceiling systems. But it's not. We don't sell or take to market a system as sales, but certainly can give advice on the most appropriate solution, really.
Okay, that's great. Thank you. Sue, I'm not even going to try and pronounce who asked this, but I'll just read it out. Can any of your resilient deck systems be used direct to joist? Also, do you have a cement particle board resilient deck products, i.e. with greater mass? Okay, sorry, it's from Rich at Apex.
Okay. No, the deck systems must be fully supported. The difficulty with fixing directly into the joist is if you mechanically fix into the joist, then that fixing is actually just like a pathway for sound to travel through. So ours are floating floor systems. So you would have your structural subdeck down first, and then you would float the deck system on top with all the tongue and groove joints glued. So yes, fully supported for the deck systems. Regarding the second query, we don't have that currently in our range, but it is something that we have done in the past. It is for a specific project or inquiry, then obviously we can look into that as well.
You could look at it bespokely. Okay, great. And Sue, again, while you're speaking away, one from Ray. Do you use timber from a sustainable source?
We do. All our timber battens are homegrown timber, but all our timber products comply with the chain of custody standards for either FSC or PEFC.
Okay, great. And last one for you, Sue. I think we've got a couple more, which I'll go to one of the guys for. Which of your products can I use in my attic conversion?
Okay. For an attic conversion, the requirement again is actually for airborne sound, and that is usually by the addition of, like quilt insulation, for example. We can supply, like microstick, for example, is quite commonly used in attic conversions, just because it provides an extra level of comfort. It provides a nicer floor finish for actually walking on, and it does obviously within the dwelling as well. It reduces the impact sound that can travel through.
Okay, thank you, Sue. So I've got one last question here. So please, if you have any more, post it now in YouTube. I probably won't be able to pick any more up through email now. So if you have one, post it there. So otherwise, Mark, we'll come to you for the last one, if that's okay. On refurbishment projects, what other factors do we need to consider with regard to the construction and compliance within building regulations?
Just a quick hello to Rich from Apex, by the way. With conversions, I guess really it depends on the size of the projects and the complexity of it, really. But it's advisable, I would say, to carry out pre-completion or sound testing before the work starts. So this could save you a lot of time, heartache, and money, really. Just get an understanding of the existing sort of sound insulation properties of the structure. And for that, you want to use an independent sort of third-party accredited testing body to carry that out for you. But I guess the thing we need to understand is that we need to sort of look at the compliance with all the building standards. So look at that in the round. So you've got fire, structure, obviously acoustics, and thermal. And it's quite important that you sort of cross-reference all of these rather than look at them sort of independently and just look at how you're going to achieve the acoustics or the thermal and that type of thing. So I guess an example of that would have been a project I did up in the Derbyshire Hills, which was a conversion of an old chapel. And we put one of our deck systems in there. Everything was going fine. They did the sound insulation test, and then the finger was actually pointed at the floor system because the sound test had failed. So we went to site and actually sort of carried out a sort of bit of a pathology exercise as to what had actually gone wrong here, and it was actually down to the actions of the building owner. So what he had done was concentrate on the thermal element, as it were, of the building standards, and he'd actually switched the specification from a 45 kg mineral wool slab. So we've got the external wall, there were timber studs put in place, and the specification was for a 45 kg mineral wool slab to go in there, and then obviously double board with plasterboard, etc. What this guy had done had actually put in a lightweight foil-faced plastic foam insulation, and used that to increase the thermal performance of the structure, but not considered really what effect that would have with the sound insulation test. So what happened is that actually this lightweight material was sort of put into almost like a drum skin. So the project actually failed due to the flanking transmission that occurred through that. So it was really costly sort of exercise, take the plasterboard off, put the mineral wool slab back in place, double board out, ran the sound test, and it worked fine. So I say we really need to sort of consider compliance with all these different standards and look at it in the round as rather than individually.
Yeah, and we would be able to help with that, look at it more holistically in terms of what, you know, what that building or client wants to achieve, and offer the best advice we can, which is great. Okay, that is all the questions I can see. And again, apologies if any others have been sent through email. I've shut that down. So we will answer them via email if any come in. If you have any follow-up questions, please email them to us at technical@proctorgroup.com, and we will answer them today, essentially. So that's been really good. I want to thank personally the marketing team, who've done another great job in preparing and sneaking my cat in. I will tell him when he comes in from his wanders, he'll be very pleased. And thank you very much, Mark, James and Sue. You know, I do say every week, it's not easy answering these questions sort of on the hoof, and you've done really well, and I appreciate your input and support. Thank you. And thank you to our viewers. We wouldn't be here if you weren't here, so thank you very much. I hope you find it educational and worthwhile. As I said, you will receive an email. Please circulate this to anyone that you may find of benefit that wasn't able to make it or didn't want to come today, and you could send it on to them saying, you know, that you might find this interesting. You can register for a CPD seminar, which has been posted down in the YouTube chat. So if you look down below, there is a link there where you can go and download your certificate. Our next webinar is already up live on the page, and you can register for it today for next Friday at 10 AM. So proctorgroup.com/webinar. Next week is all about condensation in the roof shield. We'll just call it that. Condensation in the roof space, which will be a lot orientated towards roof shield, which is a fantastic air permeable membrane, which hopefully some of you are familiar with. So again, that'll be very educational and an interesting one. I think that's it. You will receive a survey. I said earlier, you know, we do read all these surveys. It's not just done for the sake of it, and we take on board comments, and we do change the webinar structure or question, you know, how we answer the questions or the length of it, etc., based on this feedback that we get. So, you know, we will not be offended if you put a couple of comments in there that says what we could be doing better or reaffirming what's good. So thank you very much. Have a lovely weekend. Love ending the Fridays with a webinar. I know that we finish now, of course, guys, at 11. But it's a really nice way. We have our catch-up team call later on today with the much wider team, some of them who will have been watching this, and it's a really great way to end the week. So I hope everyone stays safe, that we know when we're coming out of lockdown soon. But until then, further notice, 10 o'clock every Friday, please plug in, and hopefully we can keep you entertained for an hour or so. Okay. Thanks very much, guys.
Thanks.
Right.